places near Earth and beyond the distant reaches of our galaxy to see how cosmic collisions have created our past, affect our present, and continue to shape our future. There used to be a number of theories about how our moon was formed. Not long ago, scientists proposed a new one. Let's travel back in time, 4.5 billion years, to find out what they think happened.
I felt like we were dead.
What you're seeing is the young Earth. It was a planet still forming, where life had not yet begun. In those early days, our solar system was swarming with large chunks of rock, some as big as planets. A number of them had orbits that brought them close to Earth. This one got a little too close. The collision nearly destroyed the Earth, spraying molten rock out into space. Most of this rock fell back onto our shattered planet. The rest of the rock stayed in orbit. The force of gravity kept it from escaping out into space. As these jagged rocks revolved around Earth, gravity drew them towards one another. They began to collide, fusing together into larger chunks. Within weeks, these chunks combined with others, growing bigger and bigger. And in less than a month, incredible as it may seem, our moon was formed. That's right, it only took 1 month to create our moon. This is the moon today. It's strange to think that the comforting sphere in our night sky was formed by a violent collision, but it was. In 1,000 different ways, this collision made life on Earth possible. The force of it tilted our planet's axis, giving us our seasons, and the moon's gravitational pull causes our tides. Our solar system has settled down a lot since then, so we don't have to worry about another planet colliding with Earth. But other collisions affect us each and every day. Some of the most important ones involve our sun. Don't worry, Earth isn't going to collide with the sun anytime soon. Our orbit is stable, and it should stay that way for billions of years. But all life on the surface of Earth depends on collisions that happen inside the sun. The sun is a star, like the other stars we see in the night sky. It's much closer though, so it looks different, like a gently glowing ball. But there's nothing gentle about the sun. Those dark patches are sunspots. Each of them is about the size of Earth. Sunspots look dark because they're the coolest places on the sun, only about 8,000 degrees Fahrenheit. The rest of the sun is even hotter. The sun's energy, like that of all stars, is created by collisions between tiny particles called protons. Every second, countless numbers of protons collide and fuse within the sun's core, releasing incomprehensible amounts of energy. Most of this energy leaves the sun as light. Some of it leaves the sun's surface in a continuous stream of charged particles known as the solar wind. which blows out into the solar system at almost 1,000,000 miles an hour. Or in less frequent but faster solar storms that blast particles out into space. We're looking at actual images of solar storms taken by a NASA satellite. See that static? That's a solar storm cloud hitting the satellite and overwhelming its imaging device. The solar wind blasts across the planets in the solar system every second of every day. It's so powerful that contact with it would sweep away a large portion of our upper atmosphere, removing much of our water and dramatically altering the development of life on Earth. But fortunately, Earth is protected by an invisible natural shield. What you're seeing is a visualization of Earth's magnetic field. This field arises from Earth's iron core, which makes our planet act like a big magnet, attracting some things and repelling others. Wrapped in this cocoon, Earth is sheltered from the solar wind. But some of the particles make it through this magnetic barrier, eventually reaching the North and South poles. The results are spectacular. Glorious, shimmering curtains of color. This one is the Aurora Borealis, the northern lights. Auroras occur when charged particles from the solar wind and solar storms collide with the upper atmosphere of Earth, causing atmospheric gases to glow. That's the International Space Station, circling the globe in low Earth orbit, about 250 miles up. Not many people have seen the aurora from out in space. The collisions that cause auroras happen between 60 and 300 miles above the surface of the Earth, far above where airplanes fly. And create one of the greatest natural light shows on our planet. But as we've already seen, not all collisions have beautiful and harmless results. One of them was a major factor in an extraordinary event that changed the course of life on Earth. It began out here, where asteroids orbit the sun. Asteroids are pieces of rock and metal left over from the first few million years of our solar system, when the planets were forming. Most of these asteroids orbit within the belt that you're seeing, located between Mars and Jupiter. Some can even be closer. There's only a 1 in a million chance in any given year that a large asteroid will hit Earth. But 65 million years ago, one did. It was about 7 miles wide, traveling at 40,000 miles an hour, and it was headed straight for Earth. But not the Earth we know today. This was long before humans existed, when the great dinosaurs roamed the planet. Unfortunately for them, that was about to change. The asteroid hit near what is now Mexico. The impact created a fireball that scorched everything in sight. Vaporized earth and rock were blasted into space. As this material rained back down, it heated the atmosphere. Glowing debris slammed into Earth, hitting again and again. Everything that could caught fire. For an hour, temperatures across the globe rose to more than 500 degrees Fahrenheit, literally as hot as an oven. Smoke and soot filled the atmosphere. For 6 months, it would be too dark for most plants to grow. Between massive destruction caused by the collisions and damage done by volcanic eruptions and changing sea levels, nearly 3/4 of all life on Earth went extinct. The age of the dinosaurs was over. But life is resilient, and there were survivors. A few dinosaurs made it through, eventually evolving into our present-day birds. And some mammals survived as well, giving them a chance to evolve. In fact, without this collision, we might not be here today. Could a collision like this happen again? Asteroids are still out there. If one came our way, what could we do? Blowing it up wouldn't work. We'd just end up with a swarm of rocks heading our way. But scientists have been studying and tracking asteroids for years, and they've come up with an ingenious idea. We could use the force of gravity to alter the asteroid's path. It might work like this. If you flew a spacecraft alongside an asteroid, the spacecraft's tiny gravitational pull might be enough to change the asteroid's orbit, tugging it a little off course. It would take years, but slowly, over time, the asteroid would move into a slightly different orbit, eventually ending up hundreds of miles away from Earth.
Asteroid is massive.
A few hundred miles isn't much, but it's all we need to keep us safe. Right now, this is only an idea, but it's a promising one. Many scientists think it may be our best bet. Someday, perhaps one of you will come up with an even better idea. An idea that will help protect Earth from these cosmic wanderers. We now know that a collision created our moon, and that collisions fuel our sun each and every day. We've seen the collision that destroyed the dinosaurs, and we've learned how we might prevent future collisions by using the force of gravity. All of this happened right here, in our own cosmic neighborhood. But what of the rest of the universe? And what of the future? What other cosmic collisions might be in store for us? We're leaving the Milky Way galaxy now, home to our solar system. The Milky Way is also home to hundreds of billions of stars and possibly trillions of other planets, as well as vast collections of gas and dust. Most stars and galaxies are so far apart, they hardly ever collide. But there are rare exceptions. Let's slow down for a moment on the outskirts of our galaxy. Those stars streaming past us are part of a globular cluster, a place in which stars are crammed together so tightly that they sometimes smash into one another. That was unusual. Even here, stars only collide once every 100,000 years. As we pull out quickly from the Milky Way, it's time to fast forward into the future to see what the outlook is for our galaxy and our universe. We're now billions of years in the future and 500,000 light years away from Earth. This is the Milky Way galaxy on a collision course with our nearest neighbor, the galaxy Andromeda. What you're seeing has been speeded up so that every second 40 million years pass by. Galaxies, like everything else in the universe, are constantly on the move. Even though they're very far apart, the powerful force of gravity pulls them together. These two great galaxies will swirl around each other in a graceful cosmic dance, glancing off one another and then drifting apart again. Stars and planets in these galaxies won't actually collide. They're much too far apart. Scientists think they'll simply slide past one another. What will collide are the gas and dust that fill each galaxy. And from these collisions, countless stars and planets will be born. Eventually, billions of years from now, the Milky Way and Andromeda will become one vast new galaxy. Galactic collisions are a normal part of all galaxies' lives. In fact, our own Milky Way was formed by collisions among many small galaxies. Without these collisions, the Milky Way wouldn't exist. And probably, neither would we. Cosmic collisions, dynamic and dazzling, have created so many things we take for granted. The glowing moon, the sun's warmth and light, our changing seasons, waves washing up on the sandy shore. They've ended the age of the dinosaurs and changed the very map of the cosmos, reforming galaxies and giving birth to new stars and new worlds. We humans occupy a tiny part of a vast and evolving cosmic landscape. Sometimes it feels like we're merely voyagers on a brief journey, but we are explorers, striving to understand the ever-changing nature of the cosmos. And there's no telling what our boundless curiosity will reveal to us next, in a universe made and remade, in a story of cosmic collisions.